Hi there.
Sorry about that.
Oh, it's all right.
That happens about 1 every 10 sessions, and I haven't figured out whether the problem's on my computer or whether it's with GoToMeeting. But the only fix I seem to be able to get is by rebooting, and it takes so long. It's annoying. I suppose eventually I'll have to get a second computer so that whenever it happens, I can instantly switch to the other computer and not lose.
Are you on like an actual computer or a laptop?
I'm on an actual PC, desktop computer.
Yeah, that happens with my desktop too, but honestly all computers have problems.
I know. And the solution is usually to reboot. It's just that it takes so long for computers to reboot these days that it's like it took me 8 minutes to get back online here. Anyway, back to your problem. When you talk about end behavior, the only term that matters is the highest degree of the polynomial. I don't even care. Let me change this for a moment. I don't even care what the rest of it is. This term is going to determine my end behavior. End behavior is all about what happens to the polynomial when x goes to negative infinity, and also what happens to the polynomial when x goes to positive infinity. Well, let's check negative infinity first. The easiest way to visualize this is to plug in negative infinity for x. What is negative infinity cubed?
Negative infinity.
What is negative times negative infinity?
A positive.
So, as x approaches negative infinity, y, or the function, goes to positive infinity. Okay? What happens as x goes to positive infinity? What's infinity cubed?
Just infinity.
Okay, what's negative just infinity?
Positive, negative.
Exactly. So, the end behavior is as x goes to negative infinity, the function goes to positive infinity. As x goes to positive infinity, the function goes to negative infinity. Something like this. This is a graph of negative x cubed. Notice that as x goes to negative infinity, the function comes down from positive infinity. As x goes to positive infinity, the function goes down to negative infinity. Okay?
Okay.
All right. What else?
It says graph the function x squared minus 5x plus 6 over negative 2x squared plus 6x. And my final's going to be all multiple choice, so I think that's going to be a benefit too, hopefully.
Okay. These kind of problems, usually you want to factor them to figure them out. So, how can I factor the numerator?
X minus 3, x minus 2.
How about the denominator?
We'd have to pull out a 2 first, wouldn't we?
Let's pull out a 2x. In other words, if we're going to factor the denominator, let's make sure we pull out the greatest common factor. What's left behind? What's the rest of it?
Plus 3.
Minus 3.
Oh, minus 3.
Whenever you pull out a greatest common factor, like I did just there, always make sure you do the second step, which is to multiply those two back together again to make sure you got what you started with. Notice that had I put a plus 3 and I distribute the minus 2x, I'm going to get minus 6x. Well, that's not what I started with. I started with plus 6x. So this has to be a minus. Now, if I multiply that back together again, I get what I started with. Okay? So, this function is a little unique in that there is a factor in the numerator that cancels with the factor in the denominator. And that makes a difference. In other words, this function is going to graph similar to this, not exactly the same, because when I canceled out the x minus 3's, there's still a domain restriction. I still cannot allow x to be equal to 3. Because if I allow x to be equal to 3, I'm dividing by 0. And you can never divide by 0. So this is the kind of problem where you get a hole. Whenever you have factored out something that would have been a vertical asymptote, in other words, had I not factored out the x minus 3, I would have had a vertical asymptote at x equals 3 and x equals 0. Well, now I don't anymore. Because I was able to factor the x minus 3 from the numerator and the denominator, it no longer is a vertical asymptote. It still is a hole. And when we get done drawing the graph, we'll put a little hole at x equals 3 to designate that. Okay, but for the moment, let's graph this. Where's my vertical asymptote? What makes the denominator 0?
Adding 2.
What makes minus 2x equal to 0?
Times the inverse? I don't know.
X equals 0. The only way minus 2x can be equal to 0 is if x is equal to 0. The only way you get something equal to 0 is by multiplying something that is 0. In other words, there are no two numbers you can come up with and multiply them together that equals 0 unless one of them is 0. So the moment I say that has to be true, I know x is 0 is the solution to that equation. So I have a vertical asymptote there. In other words, we can never let x be equal to 0. We also can't let it be equal to 3, but we're going to ignore that until we draw the graph. What is the horizontal asymptote?
If x equals 2?
No, you get the horizontal asymptote. There's 3 situations. And you have to memorize all 3 of them. There's the situation where the power of x is the same in the numerator as it is in the denominator, which is this case. If that is true, then the horizontal asymptote is the ratio of their coefficients. Well, this has a coefficient of 1. This has a coefficient of minus 2. The horizontal asymptote must be y equals minus 1/2. That is the ratio of those two coefficients. Minus 1/2. Now, you only use that if the power of the x is the same in the numerator and the denominator. And it doesn't matter what it is. If it's, say it was x squared and x squared there, then you still use the power of the ratios of those coefficients. The other case is where the power in the denominator is greater than the highest power in the numerator. And when that happens, the horizontal asymptote is y equals 0. And for the moment, that's the only two cases you need to memorize. Have you guys talked about oblique asymptotes?
Yeah, but I don't remember what.
You get oblique asymptotes when the degree in the numerator is greater by 1 than the degree in the denominator. And let's not talk about that until it comes up. In other words, if this was squared and I left the denominator the same, now the degree in the numerator is 1 higher than the denominator. That is going to produce an oblique asymptote. Not a horizontal asymptote, an oblique. So you have three situations. You have this situation. Horizontal asymptote would be 3, because the ratio of the coefficients is 3 to 1. You have this situation. Horizontal asymptote is y equals 0, because the bottom is a higher power than the numerator. And then you have this situation where you're going to have an oblique asymptote, and the equation of that asymptote you get by actually doing that division, and whatever you come up with is the equation of the oblique asymptote. But that's all I'll say about the oblique asymptotes for the moment. For the moment, we know this horizontal asymptote is minus 1/2. So let me make a little mark right there at minus 1/2 and draw the horizontal asymptote. Now, we're talking about a function that is hyperbolic in nature. Hyperbolic in nature means that it tends to look like this. The thing about hyperbolic functions is you got to be careful. The way I've drawn it, it's in the first and third quadrant. It can easily be in the second and fourth quadrants instead. Okay? So the very first thing I have to determine here is which quadrant it's in. Well, pick any positive number for x.
1.
Okay? If I pick 1 for x, the value of that thing is positive 1/2, which puts it right there on my graph. Right? In other words, if I plug in 1 for x, I get 1 minus 2, which is a minus 1, over minus 2, that's positive 1/2. The fact that that is in the first quadrant means that my function is in the first and third. And it approaches the asymptotes as I approach infinity. That's pretty much the definition of horizontal asymptote, is it's what the function approaches as you go to negative and positive infinity. So, this is almost the final graph. There's one additional thing I have to do to this. Show the hole. The hole is at 3. I go over here to 3, put a little hole like that right there. That means not only can x never be equal to 0, but x can never be equal to 3. And it's not evident if you look at this final function that that's true. In other words, this is a domain restriction that carries over from the original function. It is not actually a domain restriction of this function. The only reason it's there is because it carries over. In other words, this is not equal to just that. It's equal to that with the exception that x can never be 3. Is there anything else about this function they wanted to know besides vertical, horizontal, holes, those things?
No.
Okay.
No, that was it.
All right. Now, hyperbolic in nature. Let's talk about that. Here's your ultimate hyperbolic function. Has a vertical asymptote going through there, has a horizontal asymptote going through there, and it looks just like my other one did. In other words, it approaches your two asymptotes. So that's what I mean by hyperbolic in nature. But anything that looks like that, like something like this, that's also hyperbolic in nature. That's going to look very similar to this, only it would be constructed around the vertical and horizontal asymptotes. The way you always graph these kind of functions is by starting with your vertical and horizontal asymptotes and then making a hyperbolic function with respect to those asymptotes. All right, what else you got?
Elimination.
Okay.
Like where there's like 3 equations.
Go ahead.
Like, well, she didn't give me one that has like an X, Y, and a Z, but I bet you she'll have one on the test.
Well, if we're going to do one, we need one that has X, Y, and Z in it. Now, I can look one up in my book if you like. It's going to take.
Yeah,
It's going to take me a few minutes to find one. Actually see one here. Let's see. I might be looking in my wrong book. I'm looking in my pre-calc book. Yeah, it doesn't seem. Yeah, here we go. All right. I've got one that has 3 equations and 3 variables.
Yeah.
But each equation doesn't have all 3 variables. But that doesn't matter. You need to be able to solve this also. All right. How you do these is you want to eliminate a variable and create an equation for. In other words, let's number these. This is 1, 2, 3. So our strategy is going to create equation 4 that's missing one of the variables. Then create equation 5 that's missing the same variable. And then we will have equation 4 and equation 5 that only have 2 variables. And we'll be able to treat it like a system of 2 variables and 2 equations. Well, this equation, I can eliminate x real easily by adding equations 1 and 2. So what's my equation 4?
So could you
add equation 1 to equation 2?
Okay, so That'd just be 0
Okay.
plus 4y plus 4z equals 0.
Okay, there's my equation 4, no x. So now I want an equation 5, and normally I would manipulate equations 2 and 3 to eliminate x. Looks like they gave us one that is going to have an infinite number of solutions. No, it doesn't. Hold on. Hold on. This one does not have infinite number of solutions. How come? Hold on. This was not a good one to choose. Hold on. Let me do another one.
Okay.
I don't like this one because it doesn't illustrate the right stuff. Let's get one that has all 3 variables and all 3 equations. And I want to make sure we do one that has a solution, not that doesn't have a solution. All right. So our first goal is to eliminate one of the variables by manipulating 2 of the equations, and then manipulate 2 different equations to eliminate the same variable. So, which is an easy variable to eliminate?
Z.
Yeah. We can eliminate z by subtracting equation 2 from equation 1. What do I get?
You get 2x plus y equals 1.
Okay. Now let's eliminate the same variable z by manipulating equation 2 and 3. So how would I get rid of z?
You do, should you just,
You could do 2 minus 3, or you could do 3 minus 2. Either one.
I think 3 minus 2 would be better.
I agree because it's going to leave more positive coefficients. So I've got an x there. Minus y minus 2y is minus 3y. Z minus z is 0, and 4 minus 0 is 4. So I've taken my system of 3 equations and 3 unknowns and turned it into 2 equations and 2 unknowns. Well, I'm a lot more comfortable solving these, right? These are a piece of cake. Let's go ahead and solve that. We'll be able to solve for x and y. Once we solve for x and y, we'll go back to one of the other equations, substitute it in, and solve for z. So how do I solve for either x or y at this point?
So now do we need to like multiply it by something to get rid of it?
We do, because if I add or subtract right now, no variable goes away. I still want to use elimination. I want to eliminate either x or y.
You could multiply equation 5 by negative 2.
Okay, let's do that. Now, I like to do that because otherwise you end up with a ton of equations and it's very confusing. So I like to number my equations, and when I've manipulated one and changed it, I cross out the original. Okay, so now what are we going to do?
Then the x goes away.
Well, you got to add the equations. And it's important to know that you're adding them, not subtracting them. In other words, our last step was subtracting them. So you got to say you're adding them, because we have to know what to do with the 1 and the minus 8 and also these y's. I need to know whether I'm adding or subtracting. So I'm adding, so what do I get?
7y equals -7.
Okay, so there's one solution. Y equals -1. So now let's go into any of these. I'm going to take away my line, because this may be the one I want to substitute in to solve for x. I usually want to substitute the smallest equation. I could go back into this one or this one. Pick one and tell me what x is.
So what are we?
We've solved for y. We need to now solve for x.
Okay, so let's just do, we just do equation 4?
Okay.
So then, let's see, 2x equals 2, so x equals 1.
Okay, good. Okay, now we got two of the variables. To get z, we go back to any of those three equations and substitute in our x and y. We have x of 1 and y of -1. What's the easiest one here, probably?
Probably 3, right?
I think it's pretty close between 2 and 3. Doesn't matter. Okay, so x was 1, y was -1. So what is that? That's 2 plus 1, 3. Z is also equal to 1. So there's your solution. X equal 1, y equal -1, z equal +1. That's how you do 3 equations and 3 unknowns. Plan on developing an equation 4 and 5, missing the same variable, solve those, and then go back and solve for that missing variable.
Okay.
Okay?
Alright, okay, this is like for a parabola.
Okay?
It gives us the vertex, which is 9 and 2. And the focus is 9 and 7/4.
And what's the equation of the parabola?
It does it. That's what it asked for. Was the equation.
Okay. What's the general format? What's the general formula for the equation of a parabola?
Oh, shoot.
You could have two of them. Depending on the school you go to, it's either this,
And then 4.
or it's this.
Yeah, it's the 4p.
Okay? And notice that they're really the same as long as A is equal to 1 over 4p. So you could use either one, but we'll deal with the second one. What's h and k?
H is 9 and K is 2.
Okay, so we got 4p times y minus k equals x minus h squared. Well, that's almost all of it. What's p?
I don't remember how to find that.
P is the distance from the vertex to the focus. In other words, if we draw a little picture here, our vertex is right there at 9, 2. And if our focus, notice that our focus is below that. That means we're dealing with a parabola that opens down, because the focus is always inside the parabola. The focus is at 7/4, which is below 2. That means that whatever I come up with for a coefficient for either p or a has to be negative. Well, what's this distance here between 2 and the focus?
A 4.
Okay, that's what p is 1/4. Now, let's decide the sign on it later. I don't want you to get hung up or confused on figuring out what the sign of p is. You don't need to. So all you need to know is the absolute value. The distance between the vertex and the focus is 1/4. So let's make p 1/4. So now we have 4 times 1/4, or 1, times y minus 2 equals x minus 9 squared. Well, the only thing wrong with this equation is that the coefficient in front of the x squared needs to be negative. So I know that it's really a negative there instead of a positive. And I can leave my equation like this. Y minus 2 equals x minus 9 squared. Or I can move the 2 over and put it into vertex format, which is minus the quantity x minus 9 squared plus 2. Notice that that's in the original standard vertex format. If I want to leave it in this 4p format, then I would just leave it with the negative sign over here like that. One way or the other, you've got to get that negative p in there.
Okay.
The fact that you use the 4p format, I don't know if that means they want you to leave your answer in that format or they want you to always put it back into the more standard format. Some schools don't even know this format. Half of my students would not know what 4p meant. And you don't need this format. So all you need to know is the original format, and you need to know that a equals 1 over 4p. And you can deal entirely with the original format. You don't have to use this other format. But I have no problem. I mean, I think it tends to confuse the student when you introduce 2 drastically different formats like this.
Yeah, they're not alike at all.
No, I don't like it either. I would rather teach students this format throughout and just tell them that a equals 1 over 4p. That's all you need to know. And then you can deal with the a and not with this 4p on the other side. Notice that the p we came up with was 1/4. Well, in reality, it was negative 1/4 because it was measured down from the vertex. If it would have been a parabola like this, and it would have been there, it would have been a plus p. So that's how we ended up with the negative sign, was p was actually negative 1/4. But like I said, you don't really need to attend to that sign until you get to the end. as long as you know that a parabola that is based on this opens down, a parabola that is based on a positive coefficient opens up. This is this kind of parabola, this is this kind of parabola. And it makes all the difference in the world when you're talking about focus, because focus is always inside the parabola, directrix is always outside the parabola. What else you got?
Let's see. It says find the vertex focus in directrix of x equals y squared plus 8y plus 11.
From Algebra 1, you've been taught this parabola, right? Opens up or opens down. I stick a negative sign in front of that, it opens down like that. Well, the parabola we're looking at here is not y equal x squared, it's x equal y squared. Those parabolas open either that way horizontally or that way. If it's a positive coefficient, as is the case here, it opens to the right. If it's a negative coefficient, it opens to the left. Much like in the other way, positive means up, negative means down. Well, positive means opens to the right here. We need to know the general format of this parabola. Well, the general format is similar to the general format of the other kind of parabola. The h always stays with the x, the k always stays with the y. So why is my h over there? Well, it started out this way. Only reason it ended up over here is because I added h to both sides. But the h started out being x minus h. So how do I get this in this format?
I don't know.
Got to complete the square. Whenever you're trying to get a parabola into vertex format, you almost always have to complete the square. Okay? So I take my polynomial, my quadratic, I put those two terms together, and I put my number over here off to the right, like that. So far I haven't changed anything. I got exactly the same thing. Now I put parentheses around this, and I'm going to complete the square inside the parentheses. Well, the way you complete the square is you take half this coefficient and square it. Half of 8 is 4. Squared means I'm going to add 16. If I'm adding 16 to the right side of the equation, I have to subtract 16 to counterbalance it. Now, I still haven't changed the original function. It's exactly the same as it was. The 16s cancel one another out, and I still have this and plus 11. Okay? You with me?
So you wouldn't, that's kind of confusing with the 16.
Well, bear with me. Why is it confusing? I added 16 and subtracted 16. So I didn't change the right side of the equation. And you can't change the right side of the equation. The only way you're allowed to manipulate equations is if you do the same thing to the right side as you do the left side, or you do the opposite to the right side as you do to the right side. Well, in other words, I started with this. There's my y squared plus 8y plus 11. and I merely added 16 in the middle there and subtracted 16 from the right. That's doing nothing. I didn't change anything. Okay? The reason I added 16 inside the parentheses is because I want to be able to write this thing as y plus 4 quantity squared. And I can do that now. That's the whole purpose that you complete the square, is so that you can write it as a linear term, fact squared. Well, now I combine those two terms to get minus 5. And notice what I've got. I've got it in vertex format. I got x equals y minus 4 quantity squared minus 5. There's h. There's k. So your vertex is at minus 5, minus 4. You see why it's minus 4, not plus 4?
Oh, because
this thing started out y minus k. So k has to be minus 4 to result in a plus 4 here.
Right.
Okay. Whereas it was plus h. So h is minus 5. Now, a here is 1. There's a 1 right there. And I know that a is equal to 1 over 4p. So if I solve for p, I know a is 1. Multiply both sides by 4p. P is 1/4. So your focus is 1/4 inside a parabola that starts here and opens to the right. And the focus is 1/4 inside there. In other words, if that thing is at minus 5, the coordinates on my focus are minus 4 3/4, comma, minus 4. Now, did they also ask for the directrix?
Yes.
What is the directrix in this problem?
So,
First of all, the directrix is always perpendicular to the line of symmetry of the parabola.
so it would be 5 1/4.
X equal minus 5 1/4. And it needs to be the equation of a line. It's not just a point. You can't just say 5 1/4. You can't even say minus 5 1/4. The directrix is a line. So you have to give it the equation of a line, which is x equals minus 5 1/4. All right. We've got about 5 minutes. Do you have something that only takes 5 minutes, maybe?
I don't really think so. I think that kind of covered it. I'm not worried about my final. It's only 35 questions. So.
Okay. There's nothing you want to, one last question you want to ask or anything?
I don't think so.
All right. That's fine. I will wish you well on your quiz, and I probably won't talk to you again until after the holidays. So I will talk to you next year.
All right. Sounds
All right,
good.
Jade. Bye-bye.